So, my first question for you, is this a quadratic equation? No, why not? Why is this not considered quadratic, Michael? Good, because the degree of this polynomial is 4. For a quadratic, what degree does it have to be? 2. So your highest exponent for a quadratic needs to be a 2. This is a 4. Our option right now would be like, okay, let's try to factor this. I will tell you, we won't be able to factor this. Since we won't be able to factor this, I'm now thinking, let me try to manipulate this to make it look like a quadratic. What do I mean? I notice that I have a base raised to the 4th power and then the same base raised to the 2nd power. So I still have one base that's double, right, the other one. I have one base raised to an exponent. That exponent is double the other base. Exponent. So what I'm going to do is I'm going to use substitution. I'm going to let m equal x squared. Why does this help me? If m is equal to x squared, won't m squared be x to the 4th? So now I'm going to have 4m squared minus 16m plus 13 is equal to 0. Now, can I use quadratic on my m's? Absolutely. So my m is going to equal negative b, which is a positive 16, plus or minus the root of 16, well, negative 16 squared, minus 4 times 13, all over 2 times 4. All right, let's go simplify. Negative 16 squared is 256. Negative 4 times 13 will be a negative 208, all over 8. We're going to keep simplifying this. When I subtract 208 from 256, I end up with a positive 48. And now we can simplify the root of 48. I can pull out a 4. So I get 16 plus or minus 4 root 3 over 8. I'm almost done simplifying this because now I can pull out a 4 in the numerator. And when I pull out a 4 in the numerator, I'm going to end up with 4 plus or minus root 3. And then when that 4 that I pulled out in the numerator divides with that 8, I get a 2 in the denominator. I am not done. This is not my answer. Why? Even though it seems like we've done a lot of work that we should be done. Danny?
This is just m, and it has to substitute back the other way.
Good, because remember, we use substitution, so now we must substitute back. So we're going to substitute back. Remember, my m was represented by x squared. So x squared is equal to 4 plus or minus root 3 over 2. I need to solve for x. So to undo a square, I'm going to take the square root. The minute you take a square root, we need to account for positive and negative. So now I'm going to have x is equal plus or minus, I'm going to split the radical into 2. So the root of 4 plus or minus root 3 all over the root of 2. I'll let you all catch up. First thing, you are allowed to have a radical under a radical. We're fine leaving that. Are we allowed to have a radical in the denominator? No. So what I need to do is I need to rationalize. So I'm going to multiply by root 2, top and bottom. Do we agree they're both radicals with the same index? So can I multiply their radicands? But isn't this first radicand, isn't this a binomial? And I'm multiplying it by a monomial, so what will I have to do? Distribute, exactly. So now what we're going to have is we're going to have x is equal to plus or minus, we'll do this all under one radical. So 2 times the quantity of 4 plus or minus root 3 all over root 2 times root 2 is 2. I'm now going to distribute in this 2. So we get x is equal to plus or minus the root of 8 plus or minus 2 root 3 all over 2. There is nothing more I can do there, so I stop here. All right, question for you. Back to my original, what was the degree of this polynomial? Back to our original, what was the degree? Wasn't it 4? That tells me I should have 4 solutions once I solve for x. Do I have 4 solutions? Yes, because we have 2 sets of plus or minus, so that counts as 4 altogether. All right, let's do another one. Can I use the quadratic on this? No, because it's not a quadratic. If I wanted to, can I use substitution and manipulate it to use the quadratic? Yes, I can use substitution because I have x to the 8th and x to the 4th. So if I wanted to, could I use substitution and then use the quadratic? Sure. Is it necessary for this problem? Good. Why is it not necessary? Because we can factor. Don't go the longer route if you don't have to. So I'm going to go ahead and I'm going to factor this, and I'm going to get x to the 4th minus 16 and x to the 4th minus 1. How many solutions should we have at the end of this? 8. We should have 8 solutions at the end of this. Now, I did my original set of factoring. I am not done factoring. Can somebody tell me why I'm not done factoring? Kai? What are they? You're right.
They're both perfect squares.
Good. We have dots here. They're both perfect squares. So I'm going to have x squared plus 4, x squared minus 4, and then I'm going to have x squared minus 1, x squared plus 1. Anything else left to factor? Tori? Good. The x squared minus 4 and the x squared minus 1, we could factor that more. So here we have x squared plus 4, x plus 2, x minus 2, then x plus 1, x minus 1, x squared plus 1. Anything left to factor? Nothing left to factor. So now what I'm going to do is I'm going to set all of these factors equal to 0 and solve. And at the end, I should have 8 solutions. So here we have x squared plus 4 equals 0, x plus 2 is equal to 0, x minus 2 equals 0, x plus 1 equals 0, x minus 1 equals 0, and x squared plus 1 equals 0. I said every factor equal to 0. So now we solve. I'm subtracting that 4 and then rooting both sides. X will equal plus or minus 2i. This counts as 2 solutions. Next one. We get x equals negative 2. Then we get x equals positive 2. Then we get x equals negative 1 and x equals positive 1. The last one, I need to subtract that 1 over, but then root both sides, so I get x is equal to plus or minus I. Do I have 8 solutions? Yeah. Hey, not all of them are real, but it doesn't matter. I have 8 solutions. Okay, I want you to try this one on your own. Okay, let's go over this. So, is it worth using substitution and then trying to use the quadratic? Is it worth it for this one? No, because we can factor. So I'm going to go ahead and factor. When I factor, I get x cubed minus 8, and I get x cubed plus 1. What do I really hope you realize at this point? Philip? Good. We have difference and sum of cubes, so I'm going to go with that. So this is the same as x cubed minus 2 cubed, and this is the same as x cubed plus 1 cubed. So when you factor a difference of cubes, you're going to get a minus b. So I'm going to get an x minus 2, and then an a squared plus ab plus b squared. Then for the sum of cubes, when you come to factor that, you're going to get an a plus b, and then an a squared minus ab plus b squared. I will tell you, when you factor and you use a sum or difference of cubes, the trinomial will not be able to be factored any further. So I cannot factor. There are no factors of positive 4 that add to a positive 2. It doesn't work. Right? So what we do at this point is we set each one equal to 0. So I have x minus 2 is equal to 0, and I get x equals 2. Then I have x squared plus 2x plus 4 is equal to 0. Well, since I cannot factor this any further, how do you think, what do you think I'm going to recommend we do to solve for x here? Danny?
Well, okay, x then divide it to the other side.
No, because if you pull out an x and you divide it to the other side, you'll lose one of your solutions. It won't work. So right now, x squared plus 2x plus 4, that's a degree of 2, right? Which means I need to have 2 solutions. If I divide one of the x's out, I lose a solution. You want to try again or no? No. What do we do with a quadratic that we can't factor? Tejas?
Quadratic equation.
Quadratic equation, you got it. So I'm going to use the quadratic formula. X is equal to negative 2 plus or minus the root of 2 squared, which is 4, minus 4 times 1 times 4, all over 2. We now solve this. X is equal to negative 2 plus or minus the root of negative 12 over 2. I'm going to simplify that radical. X is equal to negative 2 plus or minus 2I root 3 over 2. I'm going to divide out a 2, so I end up with negative 1 plus or minus I root 3. This counts as 2 solutions. All right, next one. X plus 1 is equal to 0. X equals negative 1. And then lastly, x squared minus x plus 1 equals 0. Once again, I'm going to tell you we cannot factor this. So what am I going to recommend we do? Use the quadratic. So x will equal 1 plus or minus the root of 1 minus 4 all over 2. X will equal 1 plus or minus I root 3 over 2. So these are the remaining 2 solutions. So make sure you have, what did I need? 8, 6. 1, 2, 3, 4, 5, 6. We're good. How many people got that? Good. All right, next one. I hope we recognize something. Does anybody know what I'm hoping that you recognize? Hi? No? Yeah, it's sort of like a quadratic. Don't I have some quantity raised to the second and then that same quantity raised to the first? Right, so that is like a quadratic. I'm going to use substitution to make it more visually appealing. So I'm going to let m equal x squared plus 2, that whole quantity. So now this is going to be m squared minus 3m minus 10 is equal to 0. It looks a lot less intimidating now, doesn't it? Can I factor this? We sure can. I'm going to have m minus 5 and then an m plus 2. And I go ahead and solve it. We're going to get m minus 5 equals 0, so m equals 5. And then m plus 2 equals 0, so m is equal to negative 2. Are these my answers? No. Don't forget to substitute back in. That's the worst thing with substitution. Everybody usually gets the hang of it and does really well, but then you forget to substitute back in, and that's sort of half the problem, is what happens after you substitute back in. So you don't want to forget that. So now I'm going to sub back in. So I said m was equal to x squared plus 2. So x squared plus 2 equals 5. X squared plus 2 equals negative 2. I need to solve for x. So I'm going to subtract the 2. So I get x squared equals 3. Root both sides. I get x is equal to plus or minus root 3. Don't forget, the minute you take a square root, you have to add, when you're solving, you have to add the plus or minus in front. Now I'm going to have x squared equals negative 4. When I go to root both sides, I put my plus or minus and get 2i. How many solutions is this? 4. How come I have 4 solutions when this exponent is just 2? Any ideas, Layla?
When you distribute the exponent, it's going to be x to the 4th.
Good. If you were to FOIL these out, this out, wouldn't the biggest exponent be x to the 4th? Right, so that means a degree of 4. I'm actually going to stop here because this is where I stopped with the other class. I'm going to finish up this lesson next class, and then we'll let you work on the homework in class tomorrow. So that is the plan.